So function notation is just another way of writing y equals x squared plus 3x. That means y is a function of x. So I can just say f of x equals x squared plus 3x. The function f of x is x squared plus 3x. I can then put a whole bunch of values of x in and work out what the output is for f of x. That's inputs with outputs. This function, it says y equals 2x minus 7. That means that y is a function of x. Y is 2x minus 7. So I could describe this as the function g of x equals 2x minus 7. Once I know what the function is, I can just work out what the different outputs are for different inputs of x. So for example here, f of x equals x squared plus 3x. What's f of 1? That just means put 1 into this equation. 1 squared plus 3 times 1, which is 4. What's f of 2? 2 squared plus 3 times 2. 4 plus 6, 10. What's f of minus 3? Negative 3 squared plus 3 times negative 3 equals negative 3 squared is 9 minus 9. So I have inputs and I have outputs. If I look at g of x there, g of x equals 2x minus 7. I have inputs and I have outputs. G of 1, for example. 1 is the input. What's the output? 2 times 1 minus 7, negative 5. G of 2. 2 times 2 minus 7. 4 minus 7 minus 3. G of 100. 2 times 100 minus 7. 200 minus 7, 193. It doesn't matter what the inputs I put in. I put an input in, I get an output out. Functions have inverses. Well, some functions have inverses. So the inverse function given f of x, its inverse is f to the minus 1 of x. Let's look at g of x here. G of x equals 2x minus 7. Find g to the minus 1 of x. The method is always the same. Let y equal 2x minus 7 and just rearrange the equation to get x by itself. So y plus 7 equals 2x. Y plus 7 over 2 equals x. And now I can say, having got x by itself, that g to the minus 1 of x is, and in here I'll replace y with x, x plus 7 over 2. G to the minus 1 of x is x plus 7 over 2. And that's useful for when I wanted to find out what the x value was that produced a particular value as an output. So let's begin with g of 3 is 2 times 3 minus 7. 6 minus 7 is minus 1. The inverse function g to the minus 1 of minus 1 is minus 1 plus 7 over 2, which is 6 over 2, which is 3. So the input that produces minus 1 as an output is 3. So the inverse function on -1 takes me back to that input of 3. H of x equals, so I can have any names, f, g, h of x. H of x equals 4x plus 2. What's h to the -1 of x? Let y equal, then that implies, rearranging it, y minus 2 over 4 equals x, and that means h to the -1 of x equals. We might be given given f of x equals x squared plus 3x, g of x equals 2x squared plus x minus 3. Find x such that f of x equals g of x. That just means set those two functions equal to each other and see what the value of x is that gives that equality. So x squared plus 3x equals 2x squared plus x minus 3. We'll take the x's over that side. So 3x equals 2x squared minus x squared plus x minus 3. And we'll take the 3x away. 0 equals x squared plus x minus 3x minus 2x minus 3. Look to see if that factorizes. Equals x minus 3x plus x minus 3 plus 1 x squared minus 3x plus x is minus 2x minus 3. That implies x equals -1 or x equals 3. The input -1 into f of x gives the same output as the input -1 into g of x. So what those outputs are, let's see, f of -1 equals -1 squared plus 3 equals 1 plus 3 is 4. But g of -1 is 2 times -1 squared plus -1 minus 1 is 1 minus 3 and minus 2. Oh dearie me, that doesn't agree with what I said. Oh, that's why. -1 equals 1 minus 3, which is minus 2. Excuse my mistake. So if x is -1, they both x equals 3. F of 3 is 3 squared plus 3 times 3, 3 squared plus 3 times 3, 18. G of 3 equals 2 times 3 squared plus 3 minus 3, which equals 18 plus 3 minus 3. 18. Okay.